So, dear students, now we shall continue our discussion on problems, and this is the 18th question that we have to solve. The question is as follows: two cars starts to move at the same time from the same point. One with constant velocity 20 meter per second and the other with constant acceleration of 10 meter per second squared starting from rest. When and where will they be together? So here we have two bodies, body A, which is, let us consider the cars as body A and B, body B, and these two bodies starts from the same point. Okay, motion of both the bodies shall start from will start from the same point, and then what is given is body A or first car moves with constant velocity of 20 meter per second. The same velocity is maintained by car A throughout its motion. But car B starts from rest, the second car starts from rest, okay, and accelerates with an acceleration of 10 meter per second squared, right? And both of them are going in the same direction. Now after certain time, what happens is body B overtakes body A, right? Body A is moving with 20 meter per second constant speed, but body A starts its motion with 0 meter per second from rest and accelerates to gain sufficient velocity and to cover sufficient distance to overtake A. And now, which is the point where they will be together? Okay, the point where they will be together at the same point. So now this is again a relative case, and in this kind of problem I am going to consider the relative formulae directly, because both of them are moving at the same instant of time, which means the motion of both the bodies is happening at the same time, isn't it? Both body A and body B are starting their motion at the same instant of time. So I can take relative situation. So writing the terms first, how about initial velocity of body A? Okay, see, initial velocity of body A is equal to final velocity of body A, because the body A or car A or the first car, whatever we call, is maintaining same velocity throughout its motion. So both of them is equal to 20 meter per second. How about the initial velocity of body B? Initial velocity of body B is 0 meter per second, because it is in rest at the beginning of the motion, and the motion starts from rest. Now we don't need the final velocity of body B, because what is asked to find is when and where will they be together, which means we need to calculate when means time, right? Time shall be found, and where means after what distance, okay, after what distance the body A will be overtaken by body B. So now we have initial velocities. So relative initial velocity shall be relative velocity of body A, it's initial velocity of body A minus initial velocity of body B, which is, so UR is, or simply I can take it as U, that is also fine. UA is 20, UB is 0. So initial relative velocity is 20 meter per second. Okay, so initial relative velocity is done. Now moving ahead, how about acceleration of both the bodies? Acceleration of body A is 0 meter per second squared. Why? Because body A or the first car is moving with constant speed, isn't it? It's not accelerating or decelerating. So acceleration of car A is 0 meter per second. Acceleration of car B is 10 meter per second squared given. So relative acceleration is, see, since we considered initial velocity as ua minus ub, all other terms shall also be taken with the term a first and term b next. Okay, so it is going to be aa minus ab. Acceleration of a is 0 minus acceleration of b is 10, and hence relative acceleration of the motion is minus 10 meter per second squared. So we have ur, relative initial speed, relative acceleration, and what we need to calculate is time in which the first body is overtaken by the second body, right? The time in which the first body is overtaken by the second body. And we should also calculate the distance traveled by both the bodies, because if this is the motion happening, distance traveled by both body A and body B is equal, right? SA is equal to SP is equal to question mark, because it has to be calculated. And what is the relative displacement for this problem? When I take relative displacement, what is relative displacement? If I call it SR, it is displacement. It can be taken as displacement of body A minus displacement of body B directly, right? So now in this situation, what is displacement of body A? Displacement of body A is equal to displacement of body B, so relative displacement is 0 meter, isn't it? The distance travelled by body A is equal to distance travelled by body B, because they start their motion from the same point, they end their motion at the same point. So relative displacement is 0 meter. Using this data, we shall obtain T first, and then we can get SA or SP, both are one and the same, using a single body motion consideration. So first, applying relative situation, we have S, we have A, we have U, and we need T. So obviously the formula is S is equal to UT plus half A T squared. The relative displacement is 0. Relative initial speed is 20 T plus half. Relative acceleration is minus 10 T squared. I can take T as a common factor and send it to the other side. So one of the T will get cancelled. It will become 20 plus, plus into minus is minus. 2 ones are 2 5s are, so it is 5T. One of the T I can take as a common factor, and if I send it to the other side, it will become 0. So 20 minus 5T is equal to 0. 5T is equal to 20. So T is equal to 4 seconds. T is equal to 4 seconds, which means in time T, after 4 seconds, body A and body B will be at the same point. And from this point, body B will overtake body A and will start to move ahead of body A, right? So that's it. We have T, and now we shall get SA. Both SA and SB are one and the same, right? They're equal. So if I get any one of that, I can get that would be enough. Okay. Let me work for SA itself, because it has no acceleration. Okay. So since UA is equal to VA, the motion is uniform for body A. Okay, the motion is uniform for body A, and hence, let me write a sentence. Since first car is moving with constant velocity, we can write V is equal to, or simply VA is equal to displacement of A by time, right? You have to mention this, or else you should write S is equal to U plus AT, A is equal to 0, and then you can get the same formula. Okay, I hope you are clear with this. So SA will be VAT. What is VA? VA is 20 meter per second. T is 4 seconds. So displacement of body A is equal to displacement of body B, because both of them have traveled the same distance, is equal to 80 meter. These are the solution, numerical solution for the given problem. But we must write the answer in sentence form according to the question they are asking. See, the question says when and where will they be together? Okay, so we need to specify this point, this point where body A and body B are at the same place. Okay, we need to specify at what place are they together and after what time are they together. Okay, so the answer in the sentence form shall be written as follows. Okay, so the answer, final answer shall be written like this, should be written like this. Okay, then only you will get the full mark. Therefore, the cars, no, not the cars. Okay, therefore both the cars, okay, both the cars will be together. Okay, first is the answer for when, together after 4 seconds. Okay, after 4 seconds of the motion and for the question where, 80 meter and 80 meter from the beginning point of the motion. Okay, so this is how you should write the final answer, and hence you will get the complete mark, 5 marks for this question in the board examination. Here is the next question, question number 19 with us. The driver of a train moving at 60 km per hour sights another stationary train on the same track 100 meter, okay, it is 100 meter away, and immediately applies the brake. Determine the deceleration of the train if the accident has to be avoided, and also find the time taken to stop the train. So this is the question where we have a practical situation where the train, a moving train, has to be stopped within the distance of 100 meter. So now we shall see the situation, and this is definitely not the relative case because the second train is not moving. The second train is simply standing at the point, okay, at a point. So don't need to bother about this, about it as the relative situation. No, it is not. So if I take this as the track that we have, so on the track here we have a train standing, okay. So here is the train which is standing still on the tracks, and here is another train coming, okay. And this train has a driver, obviously, and this train is moving towards this stationary train. what is given is that this train, the moving train, is moving with 60 kilometer per hour speed and is moving towards this stationary train, and the distance between them is 100 meter. Now the train, let me take this as train A and this as train B. Okay, obviously this is not relative situation, but just for the namesake. So the moving train, the train A applies, the driver of that train A applies the brake, and hence the train decelerates, and now the deceleration should be sufficient enough to avoid the accident, which means the final displacement should be equal to 100 meter. Okay, even if it is 1 centimeter more than 100 meter, train A will crash into train B or will hit train B, and there will be an accident. We don't want that. So the displacement of train A that we want is simply 100 meter. Since this is not relative, it is a situation of train A itself. Okay, we don't have anything to do with train B because train B is stationary, and the initial speed of train A, okay, see, this is the initial point of the motion, this is the final point of the motion when train A comes at this point and stops. Okay, so this is the initial situation, and this is the final situation where this train will be here. So displacement is 100 meter, initial speed, okay, of the train A is given as 60 kilometer per hour. Now what is the final speed? Final speed should be 0 because body A should come to rest, right? So final speed should be 0. V is equal to 0 meter per second. Yeah, we need U in meter per second. So 60 into 1 kilometer per hour is, we all know that it is 5 by 18 meter per second. Okay, so it's 3 or 6 3s are 6 10s are, so it's 50 by 3 meter per second. Okay, so U is equal to 50 by 3 meter per second. We have U in meter per second, V in meter per second, S in meter. What we need is the deceleration of the train has to be calculated. Deceleration is nothing but accelerations numerically, and then we will remove the negative sign. So acceleration of the train here has to be calculated, and we should also find the time taken. So T for the motion should also be calculated. Since train B is not moving, this is a simple single body motion. This is not a relative motion. If body B is also moving, then we should have considered this as a relative motion. Clear? Okay. Now so yeah, we can work for A first and then we shall go for T. How do we get A? What we have with us is S, U and V. The formula is V squared minus U squared is equal to 2AS. Third equation of motion. What is V? V is 0 squared minus U is 50 by 3 whole squared is equal to 2. A has to be calculated. Displacement is 100 meter. So it is minus 50 squared is 2500 by 9 is equal to 2 into 100 into A. So 2 zeros gets cancelled, and A will be equal to minus 25 by 2 comes here is equal to 18. So here is the final value which has to be simplified using the calculator. Okay, so rest everything is fine. 50 squared is 2500. There you have 2AS. Okay, so it is minus 25 by 18. which is very closely nearly equal to minus 1.4 meter per second squared. What is this? This is acceleration. Okay, what we need is deceleration, so we will remove this negative sign and write it as deceleration. Right, next is we should also find the time taken to stop the train. Okay, t. Very simple, we have a with us, we have v and u with us, so we shall calculate t now. Okay, so very simple, v is equal to u plus at is the formula. V is 0, u is 50 by 3 plus a is minus, okay, we can keep it 25 by 18 or 1.4, that is fine, minus 25 by 18 t. If I send t to the other side, it will be equal to t is equal to 50 by 3 into 18 by 25, right? I have avoided one step. Okay, you can write that step also for complete clarity. In the next step, 25 by 18 t comes here, 18 by 25 it happens when it goes to the other side. 3 ones are 3, 3 6 are 18, 25 ones are 25, 2s are, so 6 into 2 is 12 second. Okay, 12 second is the time taken, and the final answer shall be written properly in the sentence form as follows. Therefore, deceleration of the train, deceleration should be equal to, remove the minus sign and write 1.5 meter per second square. This is the deceleration, and time taken for the train to stop, is equal to 12 second. Okay, that's it. This is the solution for 18th question, sorry, 19th question. And here we have 20th question, which is again a single body question, but this time direction of initial velocity will make a lot of difference in the problem. Okay, let me read the question, follow the question. A stone is projected vertically up from the top of a tower with a velocity of 19.6 meter per second. Reaches its foot, okay, this stone reaches its foot in 6 seconds. Find the height of the tower and the velocity with which it reaches the ground. So, according to the question, here we have a tower, and from the top of the tower, a stone, okay, what are the different possibilities? A stone can be simply left like this, which means initial velocity is 0, right? A stone is simply left like this. Then the second option is a stone can be thrown downwards like this, okay, like this forcibly. So then initial velocity of the motion is certain positive value, because we have considered this direction as positive. Then whatever the quantity that we have in this direction will be positive, and whatever the quantity that we have in the opposite direction will be negative. Okay, that is why the acceleration of a falling body shall be taken as positive always. Okay, because direction of acceleration is downwards, that is why. Now in this situation, what is happening is the stone is thrown vertically upwards with certain velocity. Okay, the stone is thrown vertically up from the top of a tower. Okay, vertically up. Then what happens? This stone's speed decreases and becomes 0, and then starts to fall back to the ground finally. Right? This is the complete motion of the stone. Okay, now writing the given data, initial speed of the stone, initial velocity of the stone. See, if I just leave the body like this, initial speed is 0. If I throw it downwards, initial speed is positive. If I throw it upwards like this, okay, if I throw it upwards like this, then initial speed will be negative, okay, because initial speed is directed upwards and the positive direction is downwards, that is why. So what is given is it is thrown vertically upwards with 19.6 meter per second. So minus 19.6 meter per second, and it takes 6 seconds to reach the foot. It goes up, comes back. Now during this motion, what is the displacement of the body? See, the body starts its motion from here, ends its motion at this point. Displacement is always final position minus initial position, right? Which itself is height of the tower, right? You might think, sir, the body or the stone has traveled upwards like this and has come back. What about this part of the motion? Don't need to worry about it. When we consider displacement, it's only about initial position and final position. Here, this is the final position and this is the initial position, and hence the displacement will be the difference of those two positions, which itself is height of the tower. So, okay, t, the time taken is 6 seconds. If we find height, if we find displacement, that will give us height. So s is equal to h is equal to s is equal to question mark. What about the acceleration of the motion? Acceleration of the motion is always downwards, okay? So see, because acceleration is downwards, this is the positive plus g downwards, right? So it is 9.8 meter per second square plus 9.8. So now you might be thinking, sir, the stone is actually thrown upwards. How come you take acceleration is as positive? I took acceleration as positive because in the complete motion of the stone, okay, from here to here, the final displacement is happening downwards, not upwards, isn't it? So I'm in the since the final displacement is happening downwards, I am referring to that direction of displacement and taking A, acceleration, as positive, okay? So acceleration is positive. In simpler terms, I can take whatever the quantity that we have downwards is positive, whatever the quantity that we have upwards is negative. Acceleration is downwards, it's always downwards, okay? So acceleration positive. What about displacement? Displacement is final position minus initial position, right? So that is also positive, downwards. We will get it in positive terms itself. But initial speed upwards, right? So it is negative. U is negative. H and S are positive. A is also positive because it is also downwards, right? So now we need S. Again we have the formula S is equal to ut plus half at squared. So S is equal to U is minus 19.6 into T is 6 second plus half, acceleration is 9.8, T is 6 squared. So S becomes equal to, you can make use of calculator to simplify, okay, or if you look close you have common terms here. 9.8 into 6 is a common, okay, so 9.8 into 6 is a common factor. What remains inside this? Minus 2, okay, plus 6, one of the 6 came out and the other term remained is 6. 2 ones are 2, 3s are 6, 3 minus 2 is 1, so 1 into 9.8 into 6, which is going to be 58.8 meter, okay. So H, this itself is the height. So the total displacement of the stone is this much, 58.8 meter, okay. So this is somewhat like coordinate 0, and this is coordinate 58.8 meter downwards. Okay, so S is 58.8 meter, which means height of the tower is 58.8 meter. Yeah, we need one more quantity, which is velocity of the stone. So, and the velocity with which it reaches the stone. So final velocity shall also be calculated. Very simple. V is equal to U plus AT. U is again minus 19.6 plus A 9.8 into T, which is 6 second. I can take 9.8 as a common factor. 9.8 2s are 19.6. So it is minus 2 plus 6. So it is 4. 4 times 9.8 will be 39.2 meter per second plus 39.2 meter per second. Why? Because at this point final velocity will be downwards. That is why V is positive, downwards. Okay. So the basic logic of writing equations of motion for a body moving under the influence of gravity is also like this. Okay, if you remember carefully. Okay, this is about the question and hence it is solved. Okay, but when I take the general situation for all the equations of motion for a body falling downwards, okay, we took acceleration positive plus g, right? And if the body is vertically thrown upwards, we took acceleration is minus g. That's it. Rest everything is as follows. Okay, so because we took downward direction as positive coordinate always. Okay, and we took here also downward direction is positive, initial position, final position. So displacement is also positive here. Keep it in mind. Okay, so whenever, because acceleration is always directed downwards. Okay, acceleration is always directed downwards. If you have a body moving upwards, acceleration is negative for that. But in this situation, acceleration is taken as positive because for the when I consider the complete motion, the motion starts here, ends here. So final displacement is downwards, and I have taken the direction of downward, or I have taken the downward direction itself as positive. That is why A becomes positive here. Thank you. We shall take a few more problems in the next session and end this chapter.